For this question, we're asked to find the equation of the tangent line to the curve x squared y minus y squared plus 1 equals 1 at the point 1, 0. So for this, to find the equation of this line, we're going to use the point slope formula for a line, which is y minus y1 is equal to m times x minus x1, where m is the slope of the line and x1, y1 is some point on the line. Now notice we already have the point. We know it goes through the point 1, 0 because it's tangent to the curve at that point. So it has to go through the point 1, 0, so we already know that x1 is going to be 1, y1 is going to be 0. We just need to find the slope. Now, the slope, remember, is the change in y divided by the change in x. And so the slope of this line at that tangent point is going to be the rate of change in this function, the rate of change of y with respect to x right at that point. So it'd be the derivative of y with respect to x. So we need to find the derivative of y with respect to x and figure out what that is at the point 1, 0. So let's find the derivative of y with respect to x for this curve. So first we have a product rule here. The first factor is x squared, the second factor is y. The product rule says that we're going to take the derivative of the first factor, which is 2x, times the second factor, y, plus the first factor, x squared, times the derivative of the second factor, which we're going to write as dy over dx. Minus the derivative of y squared. So remember, we're treating y as a function of x. So we're using the chain rule to say that we're first going to treat that function of x as if it were just an x. But then we have to multiply by the derivative of that function that we treated as if it were just an x. So that's going to be the derivative of y with respect to x. Plus the derivative of x is 1, derivative of 1 is 0. All right, now let's find dy over dx by moving these terms that don't have a dy over dx in them to the other side of the equation. So we'll subtract 2xy minus 1, or 2xy and 1 from both sides of the equation, and we'll get x squared times dy over dx minus 2y times dy over dx is equal to negative 2xy minus 1. Now we'll factor dy over dx out of both of these terms. And then we'll get dy over dx by itself by dividing by x squared minus 2y. So we get dy over dx is equal to negative 2xy minus 1 divided by x squared minus 2y. All right, so I've run out of space here, so I'm going to move this up here. So now we know that the derivative of y with respect to x for this curve is negative 2xy minus 1 divided by x squared minus 2y. Now we need to find out what the derivative is at this point 1, 0. So we're going to plug in 1 for x and 0 for y. So this, I'm going to write this as y prime of the point 1, 0. We're going to get negative 2 times 1 times 0, which is going to make that whole thing 0, minus 1 divided by 1 squared minus 2 times 0. So this, notice that this is 0 minus 1 divided by 1 squared, which is 1. So this is just going to be negative 1. So our slope, our rate of change of our function right at that point is going to be negative 1. So that's the slope of our tangent line. And now we're ready to plug in everything that we know into this into the point slope form for a line. So we know it's y minus y1, which is 0, is equal to our slope, which we said was -1, times x minus x1, which is 1. And so we can clean this up a bit. This is going to be y equals, distribute that -1, negative x plus 1. And there's our tangent line to this curve at the point 1, 0.